Hey, thanks for sticking around, everyone. It's a really long talk title that I put together, so I'm gonna break it down with a few pictures. All right. Why is this not working? Got to turn it on, and then complain again. All right. It's just not gonna work at all. So this talk is about templating, and it's about configuration management as well. And this is probably the maybe fourth slide we've seen like of the giant Kubernetes logo, but it is a very good logo. So this talk is also about Kubernetes, and hopefully I want to impart on you that there's more to Kubernetes than just a sort of orchestrator for your containers. And it's also about, when you do start using Kubernetes, it's about dealing with all of this YAML that you have to put up with. And so we do this with, hey, cool, it works. So we do this with custom resource definitions and a few other things. So yeah, I'm James, and I work for a company called Manifold. And we recently moved to Kubernetes about half a year ago. And I want to tell you a little bit about this and some problems that we ran into and how we got around them and sort of why it makes me excited. And hopefully it's some info that you can use as well. So we started with a monolithic application, and I think it's fairly typical how we had our sort of built out our system. But we had a infrastructure configuration that was sort of matching to this, right? So we had a single auto scale group, with a single load balancer in front, and we baked some AMIs, and then we'd take this and sort of at start time we'd use Cloud Init to pull in an appropriate container to run on there. But of course, as we added more features, we started breaking out services and developing new feature sets as different services. So while this worked well for our application code, it didn't really match the infrastructure that we had built. So now every time we add a service, we're adding a new auto scale group, we're adding a new ELB in front of it. And the sort of intentionally simplistic infrastructure architecture became like a hampering on our deploys and like our sanity of actually modifying it. So our setup was sort of Terraform was sort of the main glue for everything. We use that to do everything from our DNS to our network topology to actually doing blue-green deploys when we rolled out new code. We built our images with Packer, and there's some bash in there to actually put these images together and to do some of that initial sort of boot up. Because as we added different services with running different containers, we bring in some sidecars to handle like logging and whatnot. So our target in the new setup was to go with Terraform and Kubernetes. Terraform sort of bootstrapped through kops, which was a great way to get this sort of initial infrastructure going. And then Kubernetes to handle, like through kubectl to handle all of our deployments. Our services to do load balancing and the ingresses in front of that to actually allow traffic into the cluster. So we ended up with what I think is a pretty good sort of new, but also fairly common, architecture for our system, where we have this sort of base layer which is, configuring the cloud provider, and this is handled mainly by Terraform, but you can consider like Kubernetes manifests and kubectl being involved in this too, specifically for like external DNS, and we use Cert Manager as well. So getting sort of these lower level bits sort of brought up can actually be handled sort of through Kubernetes resources. And then on top of that, we have our cluster itself. And in the same way, Terraform like handles bringing up the leader nodes and the worker nodes. But you can also consider some of the manifests that we have to be part of this layer as well, like namespaces. and then the lovely application layer on top that's just pure manifests. And all these layers are nice and roughly segregated, and you can sort of modify one and only affect the ones above it, which is nice for speed of deploys, right? We were going from taking like 10 minutes, which isn't so bad, but was still annoying, to deploy a new version of a service to like seconds. But we started writing all of our manifests, and what you see is that you end up with things that are pretty similar, but slightly different in many ways, right? So we have all these applications, and each one has a deployment, and each one has a service in front of it to balance traffic between the pods, and then there's an ingress on top of that. And then within like the definitions of the deployment, you have a lot of duplication too. Our code is fairly standard, so our health checks all live in the same place, so we're repeating all the places to look for readiness and liveness probes. And then, on top of that, you've got duplication across environments as well. So we've got stage and prod, which look pretty similar, and then we've got our local development set up as well. So we end up with like a directory of like 2,000 lines of YAML, and then another one with almost the same 2,000 lines of YAML. So we got back to sort of this repeated complexity. And you come into it and you think, oh, we've got these YAML files and a tool to sort of apply them into the cluster, and it feels a lot like configuration management, but there's a lot of base parts that you're missing, because you're working with like a raw copy of what is stored within Kubernetes itself, right? So this would be like the start of a manifest for a deployment. It's what you have on disk ends up being the same as what you get in your cluster. There's going to be differences, of course. You have like the status of how this deployment is actually rolling out, but for the spec and this metadata, it's the same. So how do you deal with it, right? I mean, there are traditional solutions. Terraform is actually kind of ruled out because it doesn't support any like alpha or beta resources, which is where the deployment falls, for instance. We have all these, and for us, like didn't really want to introduce another tool into our flow, but there's also sort of newer tools as well, right? That's weird. Well, it just looks lighter back there. Helm and KSonnet. So for us, Helm didn't really fit. It's more akin to like RPM than Ansible. So it's a good way to sort of package up something for like, especially for other people to use. But within our setup, like we'd still have to repeat a lot of the same thing between different services. KSonnet is interesting in that it's like specific for Kubernetes, but the architecture of it is similar to any of your other systems. Like you could really easily compare it to Ansible templating, except it's much nicer. So we started looking at like what exists in Kubernetes itself, right? And you see something like the base sort of component when you start looking at things is the pod, right? And the pod holds one or more running container images. But you don't just want to run one pod, you want to run many. So you've got a replica set that holds either a fixed or an auto-scaling number of pods. But you have this one thing, this replica set that's composed of pods. And then there's deployments that live on top of that, which are like multiple replica sets. So when you actually change your code or like change some setting in a deployment and it does a rollout, it does a graceful rollout by creating a new replica set and sort of scaling up and scaling down the other two, or the two that are there. And then like looking back at the history, there was previous attempts at doing replica sets and deployments, but like the pod is always there, so it's always sort of composing on top of this. And looking elsewhere, like if we look at Docker, so this is Docker, like when there was sort of this big push of adopting Kubernetes and Docker, and it's like, hey, we're going to add Kubernetes to Docker for Mac. One of the big features was that they're going to have sort of this native integration, right? And if you use Docker Stack, you can take a compose file and you can deploy it into a Kubernetes cluster. But what it's doing is it's just taking your compose file, and it's putting like the Kubernetes metadata on top of it and pushing it to the API. So you could actually use kubectl to do this. But it runs through the API server and then gets delegated to this compose API server, which creates this compose object sort of in the Kubernetes data store. And then we have this controller that is watching for these. And it says, oh, hey, there's a new compose resource. So I know that when I see one of these, I have some logic for expanding this definition. And I'm going to tell the API server to actually create some other resources, right? So a compose file could expand out into some deployments, some internal IPs for like traffic inside your cluster, and to a load balancer service for exposing like public services. There's other examples too, like Ingresses, which I'm sure I'm pronouncing wrong, is a joint project from Ubisoft and Google that takes the pod and puts on top of it like a custom resource on top of that is specific for the needs of matchmaking for multiplayer games. So you match up 8 players for a team deathmatch or something, and your matchmaking API calls right into the Kubernetes API and says, hey, make one of these game servers. And Kubernetes runs off and does its thing, brings up a pod for it, and then sort of this added logic for the specific Ingresses part says, cool, now let's get the actual like IP and the port for this running container image, because we want to expose that directly instead of running through a load balancer to help with latency for the game. So some things we took out of this was that Kubernetes isn't just an orchestrator. It is composition, right? All of the pieces start with some base piece and add on top of that, either through usage or actually through sort of building. And the other sort of kind of weird thing is that it's also a database, right? At its core, it's pushing definitions into this API server and having them be saved there. The fact that something else comes along and reads that and then pushes out to a node and says, hey, run this container, is sort of secondary. So from there, we can look at well, what's the recipe for doing this ourselves? And this is the path that we went down, right? Is that you need a custom resource definition, you need a controller, and then optionally you can have these admission controllers. This is sort of enough to be able to define your own resources and fit them to your need. So a bunch of YAML. This is a custom resource definition. And all it really says is, hey, I'm going to reserve this namespace. So I sort of grouped under an API area, and then this is the name of the thing that I'm making. And if I'm going to say that Kubernetes is a database, well, there's no schema here, right? So it's kind of weird. But that is sort of a new feature and also optional. But you can add validation into your definition. So if you wanted to, you could define this OpenAPI v3 schema, which is a subset of JSON schema, and the ones that are actually using Kubernetes are a subset as well. So you got to be careful about looking up which piece of documentation, but for the most part, it's all sort of usable. So you can say, yeah, my specific application, it's going to have replicas, and we always want to have at least 2, right? So someone can't make one of these that has 1. And then the big part here is the controller. So if I were going to have a bunch of code besides YAML in my presentation, it would all be here. Because this is where, depending on the choices that you make, you'll have to spend like the bulk of your time, and we did. So a controller takes in an instance of your resource and then says, okay, I know, given this, what I want to have created in addition to it. So for us, it's a deploy and a service and an ingress, because most of our service are exposed externally. So with these parts, it can then say, all right, what's the state of the actual system? And then it can go and create those, right? So we wrote all of ours in Go. We used client Go, which is like, it's a very nice library for building, for interacting with Kubernetes and for building controllers that sort of live within the control plane of your cluster. But it is a lot of work. So if there was one thing that I would do, like again, it would be to start with metacontroller. And if any of you think about, like writing your own controllers and doing sort of domain-specific resources, just start here. So metacontroller is, it's basically like a way to use webhooks to create or interact with your cluster. And it comes with a bunch of patterns. So there's one that is a composite controller. And you write a webhook that just says, yeah, call me and give me the existing sort of parent and children of my resource. And then I will return what I think should actually be there. So in the simplest case, you're given in a request that says, a new one of these like applications is created, and you can just return, yeah, keep that application and also make this deploy and this service and this ingress. And it takes care of like handling the associations between those and a lot of the sort of manual work that you would usually have to do. Like we have to call the API using client Go to actually make these new resources. And then the third part of the recipe is admission controller. So again, this is actually exposed sort of as a webhook setup. And this is the way that you'd want to go. You can configure additional webhooks on your cluster. And so this is a validating admission webhook. So in this case, if you have a request to make one of these new apps come in, you can use this and you can say, well, I've got something that I can't express with like open API schema for validating this. So it comes in and your API server says, hey, is this okay to create? And then you have some sort of weird specific logic you want to say, like, no, we're not going to let you set debug and prod. And so your webhook says, like, no, don't allow this, and it'll bounce it back to kubectl or whatever. There's also mutating admission webhooks, so something that we didn't really need to use, but it's a place where you could set defaults. So if you wanted to, like in the case of the replica number, you could just say, you don't actually have to set this when you call it, but we're gonna put in 2 when it actually comes into the system. And a webhook would be, like a mutating admission webhook would be a good place for that, because it happens before it starts touching your controllers. So why, right? Like I'm talking about writing code for handling sort of what you'd usually do with some simple templating. And for us, it was because we didn't want to bring in another tool. And but there are, I think, a few compelling reasons for this too. So if we think about something like Ansible, right? You start with a template on your laptop or on, like in Tower, and the first thing that happens is the Ansible says, cool, I'm going to create these, this template means 2 deploys in a service. And then I'm gonna, call the Kubernetes API and I'll push them into Kubernetes. The difference is that if you start with using custom resources, then you can say, here's my template, and Kubernetes understands this. So I can push that up to the API, and then the creation happens over here. So this change lets us hook into the and this is probably the fifth or 10th like loop slide. But the circles are nice. So this lets us hooked into, or sort of requires us to use the reconciliation loop. So particularly if you're using MetaController, but even if you're using Client Go, most of this is abstracted away from you, but your controller will be observing the state of the system, and it'll see, okay, cool, I've got a new like application custom resource. What's the current state? So comparing what exists and seeing, well, this is the first time it's come in, so to reconcile this, I have to make a deployment, a service, and an ingress. And then we continue around the loop. And the power comes from continuing in that loop. So if someone comes along and sort of fat fingers a command and accidentally deletes a deployment, the reconciliation loop will see, observe that this was deleted and compare with the desired state and then reconcile. So this is that self-healing aspect of Kubernetes that is talked about, right? And you're able to leverage it for your own domain-specific templates, basically. Again, this is something that you would get in particularly like Puppet or Chef, right? It's sort of one of the big, one of the things that was both amazing and frustrating about Puppet when I first used it was how it would come along and change the config files that I wrote. But it is a very useful thing to make sure that the desired state of your system is the state that it's in. Another sort of really cool, probably even better point about this is that when you make your own resources in Kubernetes, they're accessible to other tooling. So this is a snippet from Ansible playbook, and this is just using the k3raw module to create a deployment. But we can just call it, with our own application and push up our own custom resource. So we can put these other tools on top of the resources. Instead of needing to run through, instead of needing to run through Ansible to make all of these different parts, you can just say, hey, use the Kubernetes API. You could build bots on top of this, or use existing configuration management, let other parts of your organization do what they want, as long as they know that this is the base area. And then the other part is that these resources that exist now in Kubernetes are almost on equal footing as the native resources. So other people can come along and build on top of what you build. So even within your own team or company, if we've defined an application, as something that has a deployment and a service, someone else can say, well, I want an external application, and they can add the ingress on top of that. So yeah, but a word of caution, I guess, is custom resource definitions, they're still relatively new, and they're not fully complete yet. The big thing is that there's no multi-version support. So going back to the Docker slide, Docker uses API server aggregation, right? They used to use CRD, if I remember correctly, but they now use an API server aggregation. And something like that, where you're shipping it to customers, is pretty important, because you want to be able to have a nice upgrade path through. With CRDs, that doesn't exist yet. You can't have something that has the same name in multiple versions. So, but like inside a company, it's not as big a deal, because you can just go ahead and give something a new name, and you're not worried about sort of this compatibility support. It's much easier to socialize the change. There's many moving parts to this, right? For us, the advantage of actually writing stuff in Go was that we were able to package everything up. So the custom resource definition is itself an API object. So at the start of our controller, we can actually look at the state of the system and say, does this CRD exist? And if it doesn't, we can make it. So we don't have to worry about shipping a separate YAML manifest to actually define the CRD first in clusters. That helps with different environments and on people's laptops and stuff. But there are, some sort of attempts to simplify this. Metacontroller, I think, does it sort of as a, as a part of everything else that it takes care of. KubeKit is something that a peer of mine is working on to sort of take things that we've been learning and, put them into a reusable library. But I think that there are, there's places here to just build something that's like, my only goal is to take in one resource and just, spit out other ones and do it like as a straight up templating. And I think that the future for these is bright, and I'm kind of excited about the way that you can use Kubernetes, not just as as an orchestrator, but as sort of a general space for storage of information and a way to manipulate that data and have effects on outside of your cluster and also the resources within it. And that's it. Thank you.